In this video, I'll be going over the definition of covalent bonding, how to identify a covalent bond, and then I'm going to just get into how to start drawing out covalent bonds. So, the overall definition is the type of bonding that happens between two or more nonmetals. So, no metals allowed in covalent bonds. In order to identify whether or not something's a metal or a nonmetal, we're going to have to use the periodic table. And so no matter how your periodic table is organized, and all of them look a little bit different in terms of colors and groups, overall it's broken up into two parts, the metals and the nonmetals. And so you want to follow this staircase. And so with the exception of hydrogen, which we'll get to in a second, everything to the left of this staircase is a metal, and everything to the right is a nonmetal. And the only exception is hydrogen. So the metals are everything inside of this black line, and the nonmetals are everything outside of it. All right, so next, in covalent bonds, electrons are shared, not transferred. And a lot of the points I'm going to go over are basically there to contrast against ionic bonding, which is probably the other type of bonding you're going over now in your class. And so with covalent bonding, it's all about sharing. It's not about giving up or receiving electrons. And so next, atoms will be neutral or have partial charges sometimes, but never any full charges. Again, contrasted with ionic bonding. So when you're drawing out covalent molecules, you don't have to worry about putting a +1 or -1 or any stuff like that on top of them. It's pretty much they're going to be neutral, and then once in a while you'll do a practice problem where your teacher is going to ask you to show a partial charge, but that's not on most of them. And so next, the bonds are drawn as sticks. When you're connecting two different atoms that happen to be in a covalent bond, you just connect it with a simple line like this. And then last in our definition, bonds represent the two electrons that are shared between the nuclei. So in covalent bonds, that stick, that bond, it really means something. It's not just there to show a connection, although it also does that. This stick literally equals 2 electrons. All right, so next, let's go over a few examples of molecules and identify if they're covalent or not. So first, we have Cl2. And so this just means that we have 2 chlorines. Chlorine is right here, number 17. It's definitely in the nonmetal category. So this means that we have one nonmetal, that's chlorine, and then another nonmetal, our second chlorine. So this molecule is covalent. So next, NaBr, we have sodium up here at number 11, and we have bromine over here at number 35. So we have one of our atoms is in the metal category. This sodium is a metal, even though bromine is not. So this means that this is not covalent. A metal and a nonmetal, that's going to be an ionic bond. All right, so next, Al2S3, we have Al right here, and we have S right here. And so aluminum, even though it's just to the left of that line, it is to the left of it. So it means that this is a metal. And sulfur, that's to the right, that's a nonmetal. So once again, metal and nonmetal, that's not the definition of just 2 or more nonmetals. So this means that this is not a covalent bond. And so last, we have H2O. So H right here, that's our exception. That is a nonmetal. And we also have oxygen over here, another nonmetal. And so this is also a covalent bond. All right, now let's go ahead and start drawing these out and get a little bit more into what's exactly happening in that covalent bond. All right, so let's take our example from before of Cl2. And knowing that our subscript is just telling us how many of that element we have, and we have a 2 here, we know this is the bond between 2 chlorines. And now I'm going to go ahead and draw in chlorine's valence electrons. And so if that sounds confusing to you or you need a refresher, go ahead and watch my video on valence electrons and then come back to this spot. But for right now, we know that chlorine is in the 7th column when we skip the transition metals in our periodic table. And that means that it's going to have 7 valence electrons. And because of our octet rule, we know that every atom wants to have a full valence shell, and so for chlorine, since it already has 7, that really means getting 1 more. It means getting 8. And so ideally, chlorine's life would go something like this. It would be in a situation where it met an element that really wanted to give up an electron. So for instance, sodium really wants to get rid of its 1 valence electron. So if these two met, sodium would just go ahead and it would just give its electron to chlorine, and then it wouldn't have any valence electrons, and chlorine would have its full 8. And then both of these would be happy. But over here on the left-hand side, our actual example, we don't have any sodiums in this situation, let's say. What if it's just a pile of different chlorine atoms? Well, what's going to happen is that these chlorines are going to kind of make a deal with each other. They're going to say, okay, we're not in a situation where either of us can get what we want, because both of us just want someone to give us an electron. So instead, they're going to make a little bargain, and the bargain is going to be, well, why don't you give me an electron for part of the time, and then for part of the time, I'll give you an electron. And so this is a really kind of weird analogy that's kind of silly, but I think it does kind of work, so just roll with me. Think of these two atoms as two friends that want to buy a really expensive pair of shoes. All right, so let's say these two friends really want this pair of shoes that's $1,000, but neither of them can afford it. They just each have $500. And so you can kind of see what's going to happen, right? If they're best friends, they're going to say, oh, okay, well, how about this? We can both just put our money together and then we can buy the pair of shoes. But then after we have the shoes, we don't want to split them up, right? That does them no good. You want your pair of shoes. So instead, the friends are going to create a schedule, and they're going to say something like, okay, you take the shoes this weekend, I'll pick them up next week, or you have them for January, I'll have them for February, etc. And we'll move the shoes back and forth between us. All right, so this again is silly, but it really is what these two chlorines are going to do. So what's going to happen is that they're going to say, okay, fine. Some of the time, you're going to be able to just take my electron. So let's say this chlorine on the right says, okay, some of the times you can have all your 7 electrons, plus you can visit mine. So then this chlorine on the left looks like this, and the chlorine on the right looks like this. But because this chlorine on the right agrees to give up its electron, it's going to say, okay, pretty soon you're going to have to just give me 2 electrons, both the one that you took from me and one of your own. And so if we go all the way up top, this kind of looks like this. This chlorine says, okay, some of the times I'm going to take yours and I'm going to take my original one back. And so if this was just you and a friend with shoes, you would make some schedule that makes sense for you guys. So these two chlorine atoms are going to make a schedule of sharing back and forth that works for them. And so what that means is something super fast. Electrons generally move at about 2,200 kilometers per second. That's enough to go around the Earth in 18 seconds. So these two electrons are being shared in this covalent bond back and forth between the two chlorines millions, billions, trillions of times every second. And so because this transfer of back and forth is so fast, so fast, so fast, in essence, it just sticks the two chlorines together. So the two chlorines don't really care about being together, they just care about having their electrons. And because electrons are moving so fast back and forth, there's never any time for the chlorines to break apart. They're now essentially just stuck together, and that's what a covalent bond is. So when I draw it out, now I just draw the stick, the line, as the two electrons moving back and forth super fast in between the two chlorines, and then they each have 6 valence electrons that are not participating in any bonding. So you can see up to my image up here, these 6 electrons that are not involved at the beginning in any of the sharing are not at the end. They're just here by themselves. And the 2 electrons that got caught in the middle of the sharing, they become the bond. So we don't show them anymore. So every time you're drawing a covalent bond, you want to make sure you understand that that bond actually equals 2 electrons, and you don't want to show those electrons anywhere else in your picture. So just to kind of finish up with the shoe analogy, basically these chlorines are stuck together. It's the same thing as if when you and your friend decided to get this expensive pair of shoes, you said, we're going to switch back and forth the shoes every 3 seconds for the rest of our lives. Well, if that was true, you would never separate from your friend again. You would always have to go to the same place, because to switch back and forth every 3 seconds, you'd have to switch back and forth your shoes, and you'd have to just be physically close to that person. And so again, the electrons are moving way faster than that, but it's an example of why sharing something back and forth so fast can make you be stuck next to something else. That's what's happening. These chlorines are stuck next to each other. All right, so now let's do one more example. That's the other covalent molecule that we had, and that was H2O. So again, starting by just drawing out valence, we have 2 hydrogens, that's our subscript of 2. So H with 1, H with 1, and O has 6 valence. Again, can't emphasize enough, if this doesn't make sense to you, go back and watch another video on valence electrons. Don't try to do this unless you totally understand valence electrons already. All right, and so now we have 1 valence, and we have 6 valence. And so everyone wants to have a full valence shell. For this, that means that H wants to get up to 2 and oxygen wants to get 8. And so the way the sharing is going to happen is, first, we're not going to connect the 2 H's to each other. If we did that, there'd be nowhere for oxygen to connect because the 2 H's would just have each of their own electron. So we're going to connect each H to the oxygen atom. So what's going to happen is, again, just think of it as that shoe analogy. This H on the left and this oxygen are going to say, okay, some of the time I'm going to give you my electron, and in exchange, the other half of the time, you're going to give me your electron plus the one you borrowed from me. So for this H, it'll be like this. Doesn't matter what electron it is, just as long as it's on the oxygen. And then the other hydrogen says the same thing. Says, I'm going to take one of your electrons for half the time, and in exchange, I'll give you mine half the time. And then the oxygen says, okay, that's great. Then what I'm going to do is I'm going to half the time take back not only this electron, but also this electron. And that's how I'm going to get my 8. So let's draw this another way. So oxygen, we can see, has 4 electrons on the top that didn't do any bonding, and now it made a bond to H and another bond to H. So now that you've seen this happen, let's do another picture that tells you how to make covalent bonds a little bit faster. So back to our valence electrons, because remember, a really important thing is that we don't want to have any electrons that are involved in bonding show up in our final structure. So what I like to do sometimes is just do the connect the dot way. So we just say, okay, this hydrogen electron, and let's just connect it to another random oxygen electron. We're going to connect those dots. Those are 2 electrons are going to form in a bond. We do the same thing over here. And now that we have that, I'm going to redraw so our picture looks nice and tidy. So oxygen, and we had in this one 4 electrons that were involved in no bonding. We made 2 bonds, and they were each connected to a hydrogen. So what we've done is basically an intro to Lewis structures. Lewis structures are all covalently bonded, and they basically tell you how to draw out more complex molecules. So, if we had something like this, it would be hard to look at all of these 1 carbon, 2 hydrogens, 2 chlorines, and immediately know how to connect. So once we get into more advanced covalent structures, you need to look up Lewis structures so that you can learn the rules of how you would connect these atoms. All right, that's my intro to covalent bonding, and happy studying. Hey, I hope you liked that video. Please feel free to subscribe, click around and watch my other tutorials, and as always, happy studying.